Massive limestone rocks are quarried, crushed. The raw materials are then proportioned and dried, and ground into fine powder. Next, the powder travels through the preheater. It then enters a rotary kiln heated to around 1450 degrees Celsius. With extreme temperature, the minerals form clinker, which is rapidly cooled. That's the journey, from rock to cement. But how does each stage actually work? Let's go back to the beginning, where it all starts, the limestone quarry.
Every bag of cement begins with mountains of raw minerals, transformed through one of industry's most powerful manufacturing processes.
The primary raw material is limestone, which supplies the calcium needed to produce Portland cement.
Large drilling machines create precisely positioned holes throughout the limestone rock face.
Controlled blasting breaks the massive limestone formation into pieces that can be transported and processed. Excavators collect the fragmented limestone and load it into enormous haul trucks. The trucks continuously transport thousands of tons of quarried rock toward the crushing section. At the plant, the enormous rocks are delivered directly into the primary crushing system. The primary crusher breaks the large quarry rocks into smaller pieces suitable for further processing. A secondary crushing stage reduces the limestone even further and produces a more consistent material size. The crushed limestone is now ready to be proportioned with the other minerals required for cement production. Clay supplies important silica, alumina, and other minerals required for clinker formation. Additional siliceous materials may be introduced when the natural limestone and clay composition requires correction. Iron-bearing materials can also be added in controlled quantities to balance the chemistry of the raw mix. The individual raw materials are stored separately before being accurately proportioned for grinding. Stacking the materials in layers helps create a more uniform chemical composition before grinding. A reclaimer then retrieves material from across the stockpile and sends it toward the raw material preparation system. Computer-controlled weigh feeders precisely regulate the proportion of every raw material. The carefully proportioned materials are transported continuously toward the raw grinding system.
The raw materials now enter one of the most important machines in the entire cement plant, the raw mill. Inside the mill, the mixed minerals are fed onto a rotating grinding table.
Powerful rollers compress and grind the minerals into an extremely fine powder.
Hot process gases simultaneously dry the material and carry the fine particles upward through the mill. A high-efficiency separator removes sufficiently fine particles while returning coarse material for additional grinding.
The resulting fine powder is called raw meal, the carefully prepared feed for the kiln.
Samples are continuously analyzed to ensure the chemical composition remains within strict manufacturing limits.
Advanced laboratory systems monitor the minerals and adjust the process whenever necessary. Once prepared, the raw meal enters large homogenization silos before kiln processing. Controlled air movement continuously blends the powder to create a highly uniform kiln feed. The homogenized raw meal is carefully metered and transported toward the preheater. The preheater tower uses hot gases from the kiln to dramatically increase the temperature of the incoming raw meal. Inside the cyclones, the fine raw meal mixes with hot gases and rapidly heats up.
The material passes through several stages, becoming progressively hotter before reaching the calciner. In the calciner, much of the limestone begins decomposing as its calcium carbonate releases carbon dioxide. This chemical transformation is called calcination and is a crucial stage in clinker production.
After preheating and calcination, the hot material enters the massive rotary kiln. The rotary kiln is the heart of the clinker production process.
At the kiln's burning zone, an extremely powerful flame produces temperatures approaching 1,450 degrees Celsius. Inside the kiln, the raw material is exposed to extreme heat and undergoes profound chemical transformation.
Near the hottest zone, the minerals partially fuse together in a process called sintering.
And the result is clinker, small, hard nodules that contain the compounds responsible for cement's hydraulic properties.
Freshly formed clinker leaves the kiln extremely hot and immediately enters the cooling system. The clinker is rapidly cooled by powerful streams of air passing through the cooler. The recovered heat is redirected back into the process, improving the plant's overall energy efficiency.
Once cooled, the clinker becomes a hard, dark gray granular material ready for the final stage of cement production.
Clinker samples are tested to verify that the required mineral phases and quality targets have been achieved.
Large storage facilities provide a controlled supply of clinker for continuous cement grinding.
Gypsum is introduced during final grinding because it helps control how quickly cement sets.
Gypsum is introduced during final grinding because it helps control how quickly cement sets.
Depending on the cement type, carefully measured supplementary materials may also be added. Automated dosing systems precisely control the amount of clinker entering the cement grinding circuit.
The clinker now enters the cement mill, where it is ground into an incredibly fine powder.
Inside the mill, thousands of tons of steel grinding media progressively reduce the clinker particles. Precisely measured gypsum is ground together with the clinker to regulate cement setting time. Continuous grinding transforms the hard clinker into the fine powder recognized as Portland cement.
A high-efficiency separator ensures that only cement particles with the required fineness continue forward.
The finished cement powder is pneumatically transported toward enormous storage silos.
These giant silos safely store finished cement while keeping different cement grades separated.
Automated systems carefully distribute the finished powder into the appropriate storage silo. Before leaving the factory, cement undergoes rigorous quality testing for fineness, composition, and performance. Laboratory technicians verify that the cement has achieved the required particle fineness. Samples are also tested for strength to ensure the finished cement meets the required performance standards. Approved cement can now be transferred to the automated packaging line for bagging. Each bag is filled with a carefully controlled quantity of cement. Automated weighing systems check every package to maintain consistent product quantity. After filling, the bags are securely sealed and prepared for final handling. Industrial robots arrange the finished bags into stable, tightly organized pallet loads. The packaged cement is temporarily stored in the dispatch warehouse before reaching customers.
For large construction projects, cement can also be transported directly in bulk tankers.
From the factory, the finished cement begins its journey to construction sites, distributors, and building material suppliers. From limestone in the earth to the cement in a construction bag,
Every stage transforms raw minerals into the material that helps build our modern world.